Let's take this JEE Advanced question. Let f r to r be a function. We say that f has property 1 if this limit exists and is finite, and property 2 if this limit exists and is finite. So as per the option, we need to see, say first option, let us test. Option A is fx equal to mod x has property 1. So let us test, is the limit exist finitely? Limit h tends to 0, fh. So if you take fx equal to mod x, then fh is what? Mod h minus what is f0? It will be 0 divided by root over of mod h. This is the limit, right? Now, is this limit exist and is finite? Let us see. Mod h divided by root mod h, it will cancel out to give you root mod h. So it will be limit h tends to 0 root over of mod h. And as h tends to 0, we can easily see that mod h is tending to 0. So root over of mod h is also tending to 0 only. So this limit exists finitely. So first option is correct because the function has the property 1. Next, option B, if we test, option B says fx equal to x power 2 by 3 has the property. So let us test that for x to the power 2 by 3, is this limit exist finitely or not? So what is the limit? It will be limit h tends to 0, f of h, that is h power 2 by 3 minus f of 0 will be 0 divided by root over of mod h. This is going to be the property, right? Now you see that here this is h to the power 2 by 3. Due to the presence of 2, we can say that the numerator h may be positive or negative because h is tending to 0. So h can tend to 0 plus or 0 minus. So h is positive or negative. For both the case, h power 2 by 3 will be positive only, right? So in the numerator, we can safely change it to limit h tends to 0. We can write it as mod h to the power 2 by 3 also, right? Because the power is even number, 2 is there. So h may be positive or negative, the result is positive. So mod h power 2 by 3 divided by denominator is mod h power half. So this is nothing but limit h tends to 0, mod h power 2 by 3 minus 1 by 2. That is limit h tends to 0, mod h power 1 by 6. So as h tends to 0, mod h tends to 0, so power 1 by 6 will also tend to 0. So this limit also exists finitely. So option B is also correct. Now let us see for property 2. Let us test for option C. If we test for option C, that is fx equal to x mod x has property 2. For property 2, we need to check this limit. Limit h tends to 0, fh will be h into mod h minus f0, that will be 0 divided by h square. Is this limit exist finitely? Let us see what is this limit. This limit will be limit h tends to 0. One h will be cancelled out, so it will be mod h by h. Mod h by h. And here lies a contradiction because here if you take limit h tends to 0 plus, when h is tending to 0 from the right hand side, mod h will be h. So h by h limit value will be 1. And when limit h tends to 0 minus, from the left hand side of 0, mod h is tending to, mod h is minus h by h, the ratio is minus 1. You can see that this is nothing but the signum function, which is on one side it is tending to minus 1, on another side it is tending to 1. So this limit does not exist. This limit does not exist. Does not exist. So I cannot say that the function satisfies the property 2. So option C is wrong. And finally, option D is fx equal to sin x has property 2. So if I substitute in the property 2 for option D, it will be limit h tends to 0 sin h minus sin 0, that is 0 by h square. This is the limit. Limit h tends to 0 sin h by h square. So this is nothing but limit h tends to 0. As h is tending to 0, sin h can be written as h only. Okay, we can write it as h minus h cube by 6. Let us take one more term divided by h square. So this is becoming limit h tends to 0, 1 by h minus h by 6. So clearly you can see this term is tending to 0, but 1 by h. What is happening to 1 by h? 1 by h as h tends to 0 is of course one side when h is tending to 0 plus, 1 by h is tending to plus infinity. When h is tending to 0 minus, 1 by h is tending to minus infinity. That means we can say this limit does not exist at all. So option D is wrong.